Let's touch on a couple of more points, sectors. So this is a disaster risk reduction with S2S forecasts. The needs are listed here and the lead time is listed here. This is diagrammatic illustration of the food security climate resilience facility developed by WFP, World Food Program, to support community-centered action to build and reinforce resilience. So this is user engagement. Similar to the concept of forecast-based funding, Food Secure links climate and hazard forecasting with flexible multi-user financing, providing governments with the means to unlock funding quickly to scale up food and nutrition responses, as well as the disaster risk reduction activities before an event occurs. So this is fitting well into the Ready, Set, Go framework. So you can see anticipatory action and preparedness using climate forecast, early warning data received, trigger point is set, anticipatory community action and preparedness to build resilience. You ramp up the activities to emergency declared, complement existing response mechanisms. So early response, early action plans go into action, implementation, recovery and resilience and building after the event is over. So build long-term climate resilience at community level predictably. Okay, so that's the kind of a framework. Now there is a new Sendai framework for disaster management and maybe disaster risk reduction. Obviously similar thing can be done for each sector as well. This is focused on food security, but now you have to also consider the so-called nexus between food and water, and also food, water and energy. And I think health should also be added to it, especially in the tropics where health is very much dependent on food and water, for example. This is an example of a coastal decider monthly regional summary forecast for England and Wales on December 11, 2017, using the monthly system for European ECMWF. I won't read the whole thing. Okay, so you can see again the information being given here. Coastal decider for England and Wales. This is showing probability and the times here of the various things. So regional forecasts show the probability of high-risk weather patterns that are relevant for surge events, storm surge, along different coastal stretches. Flooding is always a big risk with massive damages if you don't plan properly. Climatologies of these high-risk surge-related weather patterns, dashed lines in the plot, and the UK mean sea level pressure anomaly forecast is provided for context. Distance and correlation plots are used to assess how good the match is between ensemble members and their assigned weather pattern. So some detailed information is given. This is still kind of maybe too complicated for a general user, but these go to trained decision makers who are doing the coastal deciding in terms of operating levees or preparing disaster management and so on. Okay, so that's the sectors and the engagement, communication and dissemination. Let's conclude with summary and recommendation for future research. This chapter has revealed the low level of maturity of S2S communication in current published work and operational systems, with communication, dissemination and engagement strategies rarely being considered in the design, development and rollout of these services. So other than Australia, others are still a bit behind. Based on this review, the following recommendations emerge, many of which are applicable beyond the S2S timeframe. Okay, engagement with users is essential to provide actionable forecast information. This is another key word that has evolved: actionable information, not just forecasts, but forecasts that can actually be used for action, decision making. I won't go into the detail here, but current strategies for user engagement include workshops, surveys, seminars and one-to-one interviews, as well as consultation exercises and collaborative discussion sessions, etc. Education outreach is a critical component to improve user comprehension and sustained uptake of S2S. Collaborative and co-produced tools to aid decision making are essential and must extend across research disciplines. So this is the idea of going from just forecasts of precipitation, temperature, and so on across into what is needed in agriculture, in health, water management, and energy management, and so on. Successful communication, dissemination, and engagement should improve understanding and empower user communities. So users should feel like they are actually able to choose some things to get the information specific to them using the probabilities of temperature or precipitation, weather events, and so on and so forth. Okay. Given the uncertainties, you can read the details in the book. I'm just giving you a sampling. Given the uncertainties associated with the S2S timescale, it's important to consider the information management and the structure that this should take when applying S2S forecasts in early warning and disaster risk reduction. Okay, obviously it's not easy to understand uncertainties at a user level, but constant education can let them decide what it means when it says something like 30% probability of a storm surge or a 30% probability of a major snowstorm, and so on and so forth. There remains very little access to privileged applications known or thought to be in place in the private sector. So insurance industries, energy, or military applications are very good at doing their own internal research and taking the forecasts. They don't necessarily do forecasts, but they ingest the forecast from national agencies and do their own impact calculation, probabilities, risks, planning, and so on. And that information is not necessarily available to common laypersons, general public. So greater effort should be made by the meteorological, hydrological services, university researchers, and non-government groups to engage and partner with private sector organizations to identify areas of knowledge that could benefit public health and safety that may be shared without compromising commercial services and classified information. For the development and integration of communication aspects both in research and operationally, there is a need for explicit and systematic documentation, evaluation, and publication of all aspects of S2S information, communication, and use. This is a general truism. Furthermore, there needs to be a sustained effort to design, pilot, and operationalize new S2S services and measure their effectiveness and usability over years, not months, or the life of a traditional research demonstration project. So this is a issue of how to fund the development, who operationalizes it, and then who improves it, and how this communication between the tool developers, tool operationalizers, and tool users happens. This is an issue of funding and how the funding is set up in different places, and whether some agencies consider it their responsibility to fund it, or whether the government sets up the proper communications between research and operational agencies and users, and so on. Because some people may be very good at improving forecasts and they don't really care about how it is communicated and disseminated. So then who does the linking? Like extension agents in agriculture. So you need these kind of gaps to be filled over time. Okay?